Hey everybody, this is Mr. Storm. In this video, we're going to talk about how to create some math operations and how to make your computer do some math for you, which is going to be pretty cool. I'm going to organize my brackets here because that's going to drive me nuts. Some of you last week were having some issues with bracket confusion. The easiest way to avoid that is just to make sure your brackets are on the same level here. So yeah, there we go. We're good on brackets. I'm going to change this hello world to, let's do operations. Alrighty. Okay, so let's talk about math a little bit. Doing math in a calculator is pretty easy, right? You just push in the buttons, boop, 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 you hit the thing, and then it shows you the result. You don't have to do any like writing it down, carry the 4, any of that stuff, right? Well, computers are really just advanced calculators. And when we're writing programs in C#, we can actually kind of tell it to behave like a calculator. Let me show you an example, right? So we did some variables last week. We learned how to use variables. I'm going to create an integer variable. I'll call it num1 to be my first number. And I'm going to say it's equal to, I don't know, 897. Okay. And then I'm going to create another integer variable called num2. And I'll say it's equal to 87,569. Okay. Now, if I wanted to add those numbers together, I can get out some pen and paper and I could actually do the math operation. But why not just make my computer do it for me? So what I could do is I can say, I want a third number. And I'm going to call this sum, and I'm going to say it's equal to 89, or no, I don't even need to put in the numbers. I want to say it's equal to num1 plus num2. So now sum is going to add num1 and num2 together, and then it's going to hold the value, right? So I can then, console.writeLine sum. So if we run this program, we should see what the sum of 897 and 87,569 is. So I'm going to hit run, and it looks like it's 88,466. Now I'm pretty sure that's correct. I'm not actually going to do the math to check, but the computer's better at math than I am anyway. So that's fine. I'm okay with that. Now, it's not just addition you can do with C#. There are other operations you can perform as well. You can say things like sum equals num1 minus num2. We can do a minus as well, right? Let's output that onto the screen and see what that looks like. So we can subtract a number. So that's negative 86,672. Okay. We could also num1 and looking for my asterisk there, asterisk num2. Now the asterisk is actually just multiply. So we can do a multiplication as well, right? So console, oh, you know what? I already have it copied. I can just paste it. And actually, I realize I'm going to run out of screen space pretty quickly if I keep giving myself so much space. So then it looks like, ooh, what is that number? 78,549,393. I mean, you see how quickly the computer does this math? I don't have to worry about it, right? Let's do another one. Sum equals num1 divided by num2. Now, here's a weird one, because notice that my number variables are integers. They're integers. So they can't be a number with a decimal point. They have to be whole numbers. So I'm going to divide these numbers. I know there's going to be a decimal there somewhere. This isn't going to divide evenly. I'm not going to be able to divide 897 by 87,569 and not have a remainder. So let's see what actually happens when we do that. So notice it just goes to 0, right? If I were to change these to floats, hold on. Actually, I don't even have to change these to floats. Oh yeah, I do, because I want to make sure I keep the same type. This one definitely has to be, let's see if that can stay in int. Now let's change this to float as well, because that's the first time we're creating some. Sorry, I'm just talking out loud. Thinking out loud. Talking out. I always talk out loud. I'm thinking out loud. All right. I'm going to hit run and see what happens now. Okay, so notice that before, a couple things changed. One was that big number that we multiplied, instead of being 78 million, it converted to 7 point whatever plus, with the E plus that scientific notation right there, because the number is very, very big. With an integer, it just told us it was 78 million whatever. With this, it actually converted it to scientific notation. Also with a float, when we divided, we did our division problem, but we noticed we now have a remainder. That's very, very important. Now, there's another operator I want to show you, which may take a bit of explaining. So let's get into it. So num1, then I'm going to use this symbol. Now, you might be thinking, oh, Mr. Storm, I know what that is. That's a percent sign, right? Well, yes, but in this context, it does something completely different than what you're expecting. So let me go ahead and run this, and we will see if we can figure out what it is that it's doing. It's giving me 897. Well, that's not correct. Here's what it's supposed to be doing. Maybe let's make my numbers a little bit easier to understand. Let's do 10 and 3. How about that? Make my math a little bit easier. So if we look here, our addition, we have 13. With our subtraction, we have 7. With our multiplication, we have 30, because 10 times 3 is 30. With our division, we have 3.33333333, right? Because that is what 10 divided by 3 is. Now notice here with this percent sign operator, we get something else. We just get 1. Here's what this is doing. This is called a modulus operator, and the modulus operator will allow us to do a division, but instead of showing us what's on this side, it'll show us the remainder. Now, notice that my remainder here is 333 repeating, right? But then the remainder they showed us was 1. This is just essentially, modulus is mostly used as a way to determine if a number is even or odd. And we're going to get into modulus a lot later when we get into like if-else statements. But for right now, just notice that that's not actually percent. What it does is it divides and it shows us the remainder, not the whole number that goes before the decimal. Okay. Let's see. What are we going to do? Okay, so this is basic math. This is simple math, right? Well, the thing is, we can actually do some really complicated math as long as we respect order of operations, right? So if you remember order of operations, it's Pemdas, right? Please excuse my dear Aunt Sally. And that stands for parentheses, exponents, multiplication, division, addition, subtraction, right? This is the order in which our computer will solve our problems. So let's think of a Pemdas problem, console.writeLine. So let's say 10 times 2, but within here, I'm going to say 10 minus 1. Now, if I did the multiplication first and I said 10 times 2, actually I don't even need these here. So yeah. Okay, so 10 times 2, this is multiplication. 10 times 2 is going to go first, right? So that's going to make this 20, and then it'll be 20 minus 1, which makes this 19. But if I put parentheses around the 2 minus 1, then that becomes 2 minus 1 is 1. 10 times 1 is 10, right? So the parentheses, that's the P in Pemdas, the parentheses tell us that we have to do this operation before we do this operation, okay? And it gets even more complicated, right? Exponents. If we have an exponent number like 10 to the 15th power, right? Now, multiplication and division, they happen essentially simultaneously if we have a division problem before the multiplication. So let's say we had a division here, and instead of, let's make that a 15. And this was multiplication. Now, if we were doing it exactly the way Pemdas is normally written, we would do 2 times 15, which is 30, and then 10 divided by 30 would be 3. But it's actually, these two kind of go together. So 10 divided by 2 is 5. 5 times 15 is whatever. So let's see what that ends up being. 75, right? So notice that even though D comes after the M in Pemdas, it actually should be more like this. Right? So parentheses, then exponents, then multiplication and division, whichever one is first in order, and then addition and subtraction, whatever comes first in order. So your order of operations is going to be important when you're developing your functions, your whatever math functions you're going to create. In the calculator project, you're actually going to create a calculator that takes in a formula, or that takes in numbers from a user, and it spits out the answer to a formula. For example, if you were doing something like volume of a cone, right? And you would ask them for the 3 or 4 things they need to enter, it would spit out the total volume of that cone. Now, here's the problem. Right now, all I'm doing is just kind of hard coding these numbers in here. What happens if I try to get my user to enter a number into the screen? Well, the way we did it last week for strings was just like this, right? I can say num1 equals console.readline, and then we could go for it. But watch what happens when I do this. Is it running? There we go. Okay. So right here, it's giving me there's an issue here. It says cannot implicitly convert type string to float. What that's telling me is that this statement right here, console.readline, this is a string, meaning whenever I type whatever I'm typing into my console there, it's going to come into my program as a string, and it's going to try to be stored in a string variable. But num1, as we can see from up here, is a float. So strings can't go into float variables. So we've got to do one of two things. We either have to change the float variable to a string, or we have to change the data coming in to a float so it fits in the float variable. Does that make sense? It's like taking a circle hole and trying to fit a square peg in the circle hole, right? They won't fit. We either have to change the hole or the peg. Okay? So what we're going to do is we're going to use something called parse. Parse statements are incredibly useful. Parsing is essentially just interpreting. It's just a fancy way of saying interpreting. I'm going to interpret this data as another kind of data. Okay? So here's how we write a parse statement in C#. Now, we're going to use a method called try_parse, but first we have to indicate what type of data do we want our string to convert to, right? So in our case, it's going to be a float. So float dot, and then capital try, or capital T try, and then parse. So notice that the words are together. It's just like when I'm doing write line or read line. The words are together, but the parse is capitalized. Now inside the try parse statement, we have a couple things we need to do. First, we need to indicate what is the data that I'm going to parse. What is the data I'm going to convert? And in this case, the data that I'm going to convert is the console.read line. This means whatever's coming in on the console read line, we're going to try to parse it. We're going to try to turn it into something. Then I use a comma. The second section, we're going to start with with the keyword out. This is saying I want whatever's in the console read line to get turned into a float, and then it's going to be spit out to a variable. And in this case, I'm going to say the variable is going to be sum. So this statement is how you're going to bring in data into a different variable type other than a string. Up here is for a string. Down here is for any other data type other than a string. So this is how you do it. Pay attention to this line because you're going to need it a lot in this power standard. So again, float is the type of data we're converting it into. Dot try parse, that's the name of the method we're invoking here. Then inside the parentheses, we have two statements. We have one that is the data that we will convert from. We're going to convert this data into a float. And then we have a comma. And then we have our keyword out. And then we have the name of the variable we're going to put this data into. All right. Let me comment out that line so it won't give me this error anymore. And I'm going to run it and see what happens. So notice that I have a cursor here, and it's going to let me type some information. 59, whatever. Now the program's over. That wasn't really smart. Maybe I should put something out here. So if I go into my, let's do console.writeLine, and let's say we're going to add sum plus, I don't know, 12. So we're going to output the value of sum plus 12. So let's run it. Okay, so I'm going to add, let's see, 87. So sum plus 12, so 87 plus 12 is 99. So notice that because it's a float, we can actually do math with it, right? And the nice thing is the console write line isn't that finicky about displaying data. It can display your float variable onto the screen. It doesn't need it to be a string, so we don't need to then reconvert it back into a string. The write line just does it for us. So that should be about it for operations. With all of the stuff that we've gone over today, you should be able to build a calculator program. Now I'm going to show you an example of a calculator for the power standard, but I am not going to show you how I wrote it, okay? That's very important. This lecture shows you how. The video in the calculator project just shows you what I did, okay? That's important. I'm not going to walk you through this one step by step. We've done that for a couple of weeks now. Now it's time for you to take off the training wheels and be a big boy and do this on your own, all right? But if you have any questions or if you get stuck, please let me know. Again, this is a power standard. I want you to do well on this. So if you need some help, please let me know and I will help you out. Okay, that's it for me, and I'll see you in the next video where I show you my calculator. All right, peace.